Hello and welcome to this video which focuses on the shortest distance from a line to a point. Some of the prior knowledge that will be helpful for this video would be 2-dimensional and 3-dimensional lines, basic velocity vectors, and the dot product. We're going to start off this by drawing out this situation. So we have, let's say, a beach and we got a point P. Let's say your friend is standing there and we got a boat which is riding on let's say the water, and it's got a direction vector b, and we're going to draw different lines which represent the distance from you to, let's say, the boat. And the shortest distance, as you can see in the diagram, is the one which is perpendicular to the line. In this case, we're going to say that the closest distance happens when vector PR is perpendicular to vector AR. And in terms of terminology, R is the foot of the perpendicular from point P to the line. Since the two vectors are perpendicular, that means their dot product is going to equal to 0, or that the dot product of PR and direction vector B is going to equal to 0. Because of this, we can use this idea to find the parameter t for which the dot product of PR and AR is equal to 0. So let's look at an example of this. In this example, we want to determine the coordinates of the foot of the perpendicular from point 2, 0, 1 to the line that's shown here. To start this question, I personally like to draw out the situation. So I'm going to draw a line which is going to have an initial point of 3, 4, and -1, and a direction vector 2, -1, 1. Then I'm going to draw out point P, which is going to have coordinates of 2, 0, and 1. And I'm going to draw the perpendicular line from the line to that point, and I'm going to label that as point R, which is going to have components x, y, and z. We can find vector PR, and it's going to be the coordinates of point R minus coordinates of point P, which is going to give us x component of x minus 2, y component of y, and z component of z minus 1. And now we know that the vector PR and AR are perpendicular. So that means the dot product of PR and direction vector B is equal to 0. We know the components of vector PR and the components of B are 2, -1, 1. So we can multiply the x components, the y components, and z components together and sum them up and set them equal to 0. When we do this and expand and simplify, we'll end up getting 2x minus y plus z minus 5 is equal to 0. Now we know x, y, z are the components of vector R, so x is equal to -3 plus 2t, we can plug that in. Y is equal to 4 minus t, we can plug that in. And z is equal to -1 plus t. And we will plug all of that in, and then we will expand the equation and we will simplify it, and we will isolate for the t value. After doing a little bit of algebra, we will get 6t is equal to 16, and t simplifies here to 8/3. Okay, now we know that x is equal to -3 plus 2t, y is equal to 4 minus t, and z is equal to -1 plus t. And we already have the t value, so we can plug the t value there to get the x, y, and the z component of point R. We will get the x component to be 7/3, the y component to be 4/3, and the z component to be 5/3. And those are the coordinates of point R. Once we have all the points, we can also determine the shortest distance from the point to the line. In this case, since we have the point, we know the vector PR, and the magnitude of vector PR will be the shortest distance. So to find PR, we will subtract all the components or all the coordinates of point R by point P. So that's 7/3 minus 2, 4/3 minus 0, and 5/3 minus 1. And we will get 1/3, 4/3, and 2/3. the magnitude is going to equal to the root of the x component squared plus y component squared plus z component squared. And once we plug everything into our mighty calculator, we will get that the magnitude, or the shortest distance here, is approximately 1.53 units, rounded to 3 significant figures. Now, the summary of this lesson is provided here, and it's fast forwarded, so if you want to pause the video and write down any of the information, please feel free to do so. And now we're going to look at another example. In this question, we got Robo, who is moving in direction 6-8 at a speed, I made a mistake, this should have said speed, of 5 kilometers per hour. If Robo's initial position is at -10 and 5 kilometers, determine the time when Robo is closest to position of 15 and 4 kilometers. Note that in this question, we have the speed, but we don't actually have the proper components of the velocity. So the first challenge is to figure out those components. We know that the direction vector, in this case, has components of 6 and 8, so its magnitude is going to be the x component squared plus the y component squared, which is root of 100 or 10. We know that the speed is equal to the magnitude of our velocity, and our magnitude of the velocity here is 5 kilometers per hour, which is same as 1/2 times 10, or 1/2 times the magnitude of our direction vector. So this means that if we want to find velocity, is 1/2 times our direction vector, which will end up having an x component of 3 and y component of 4. We can check this also. To get the speed here, we will take the x component squared plus y component squared and take its root. That's root of 3 squared plus 4 squared, which is root 25 or 5 kilometers per hour, which is consistent with our speed. Now that we have this, we know that the line that Robo is traveling in can be defined as xy is equal to -10, 5, which is its initial position, plus t times the velocity vector, which is 3, 4. Once we have this, everything else is done as before, so we're going to draw out the line. In this case, we will have components -10 and 5. That's the initial position. Our velocity vector has x component of 3 and y component of 4. And the point that we're comparing, we're trying to get the shortest distance from, is point 15, 4. Now we know that the vector PR and the direction vector or the velocity vector are perpendicular, so that means that their dot product is equal to 0. We have the components of velocity vector, that's 3 and 4. For vector PR, we will take the coordinates of r and subtract them by coordinates of p, and that should equal to 0. Now we will multiply the x components together and the y components together and sum them up and set them equal to 0. Now using the distributive property, we will get 3x minus 45 plus 4y minus 16 is equal to 0. We have the 3x plus 4y, and they're not like terms, and we add all the constants together to get minus 61 is equal to 0. Then we're going to replace x with -10 plus t times 3 and y with 5 plus t times 4. And we're going to set that equation to equal to 0 in order to solve for our t value. After we expand and simplify, we'll end up getting that 25t is equal to 71, meaning that t is either equal to 71 over 25 or that it's equal to 2.84 hours. I have left you with 2 practice questions to try on your own, and I will try to post a solution to these as soon as I can on a separate video. I hope that this video was helpful in giving you an idea about the shortest distance between a line and a point, and also the foot of the perpendicular to the line as well. Thank you for watching.